Namaste everyone, welcome to the class. Today we are going to see quadrilaterals. So what is a quadrilateral? You must have learned about quadrilateral in your previous class also. Quadrilateral is a four-sided closed figure. Four-sided closed figure, something like this. Okay, this could be sometime like this also, means it is bounded by four sides. Let us see few properties of quadrilateral. The first property is angle sum property of quadrilateral. Angle sum property of quadrilateral. Now what is angle sum property? Angle sum property of quadrilateral is that the sum of all four angles of quadrilateral is 360 degree. So if I draw a quadrilateral ABCD, then sum of angle A plus B plus C plus D is equals to 360 degree. We can prove this by dividing this quadrilateral in two triangles. Now triangle ABC, if I mark this as angle 1, this as angle 2, this as angle 3, this as angle 4, 5 and 6, then sum of this angle 1 plus 2 plus 3 is 180 degree. That we already know that sum of all three angles of triangle is 180 degree. And similarly, sum of angle 4 plus 5 plus 6 is also 180 degree. So if I add these two equations, this is equation 1, this is equation 2. If I add them, this angle 1 plus this angle 6, I can write as angle A, plus angle 2, I will write as angle B, plus angle 3 and angle 4. So this angle and this angle, they will club together 3 and 4 and it will be angle C, and this finally this angle 5 is your angle D. And here 180 degree plus 180 degree is 360 degree. So sum of all four angles of quadrilateral is 360 degree. Quadrilateral has four sides, quadrilateral has four vertices, and it has two diagonals. So AC and this BD are called diagonal. AB, BC, CD and DA, they are the four sides of quadrilateral. Side AB and side DC or CD are opposite sides. Similarly, AD and BC are opposite sides. AB and BC or AB and AD, they are called adjacent sides. Now, let us see types of quadrilaterals. Types of quadrilateral. So, we have few types, like first we will discuss trapezium. Trapezium is a quadrilateral in which one pair of opposite side is parallel. So in this ABCD, in quadrilateral ABCD, if AB is parallel to DC, okay, so if one pair of opposite side is parallel, then this is called as a trapezium. Now side AD and side BC, they are called non-parallel sides of trapezium. Side AB and side BC are parallel sides of trapezium, and side AD and side BC are non-parallel sides. Now in trapezium also, if this non-parallel side is equal in length, then it is called isosceles trapezium. So in trapezium, we have one type called isosceles trapezium. So in isosceles trapezium, this non-parallel side, that is AD and BC, they are equal. So for isosceles trapezium, we have AB parallel to DC and we have AD, side AD is equals to side BC. So AD is equals to BC. Now, when a trapezium is isosceles trapezium, then base angles are equal. So angle A and angle B will be equal. We can prove all these things. Angle D and angle C is equal. And diagonal AC and BD, they are also equal in length. Next, let us discuss parallelogram. Now, if in a quadrilateral, both the opposite pairs are equal, then it is called a parallelogram. So, in parallelogram, suppose this ABCD is a parallelogram, then AB is parallel to DC and AD is parallel to BC. So, a quadrilateral is called as a parallelogram if their opposite sides are parallel. Both the pair of opposite sides are parallel, that is AB is parallel to DC and AD is parallel to BC. Now, in case of parallelogram, we can prove that. So, there are few theorems. Based on those theorems, we can prove certain things. So, those things we can consider as the properties of parallelogram. So, first, what we can prove? We can prove that this parallelogram, okay, if I draw any diagonal, then the diagonal divide the parallelogram into equal areas. Okay, so first two equal areas you say are two congruent triangles. So I will say that diagonal of parallelogram divides it into two congruent triangles. You can prove it. How you can prove? This angle BAC and angle DCA, they are going to be congruent because they are vertically, they are alternate angles. Side DC and side AB is parallel. In the same way, we can prove that this angle C and this angle A, okay, that means angle BCA and angle DAC, they are also congruent. Again, they are alternate angle formed by two parallel angles. And side AC is common between these two triangles. So these two triangles you can prove they are congruent. Once you prove that these two triangles are congruent, next you can prove that opposite sides are equal. So first property is that diagonal of parallelogram divided it into two congruent triangles. Second, you can say that K opposite sides of parallelogram are equal. I will encourage you to go through your chapter and there you will find all these proofs. Opposite sides of parallelogram are equal. Third, Third, we can prove that opposite angles of parallelogram are also equal. So when I say opposite sides of parallelogram are equal, that means I will say that this side AB will be equal to side DC and this side AD is equal to side BC. Third, I am saying that opposite angles are equal. That means angle A will be equal to angle C and angle B will be equal to angle D. Okay, this is also very simple to prove. As here you can see that if I mark this as 1, this angle will be equal to 1. If I mark this as 2, this will be equal to 2. So this whole angle is angle 1 plus angle 2 and here also it is angle 1 plus angle 2. So opposite angles are equal. Fourth property is that diagonals of parallelogram, they bisect each other. Fourth property is diagonal of parallelogram bisect each other. Now what you understand by they bisect each other? So by saying that they bisect each other means if suppose I consider this intersection point as M and this quadrilateral as or this parallelogram as ABCD, then AM will be equal to CM and BM will be equal to DM. So this is what we understand by diagonal of parallelogram, they bisect each other. Fifth property. So actually we have discussed all the properties. That first we understand what is a parallelogram. When the opposite pairs are parallel, then it is a parallelogram. Both opposite pairs means here we have four sides, so we have two pairs, opposite pairs, and both the opposite pairs are parallel, then it is a parallelogram. Now when it is a parallelogram, you will find that opposite sides are equal. So what you can say that when opposite sides of a quadrilateral are equal in length, it is a parallelogram. Okay. Next we have seen that opposite angles are equal. So again you can say that if opposite angles are equal, then it is a parallelogram. So these are all converse statement. Third, we have seen that diagonal bisect each other. Okay, if it is a parallelogram, diagonal bisect each other. So conversely, I can say that if diagonal are bisecting each other, then it is a parallelogram. Okay. Now one more condition is that we have discussed that in parallelogram opposite pairs are parallel. But if one pair of parallelogram is parallel and equal, then also it is a parallelogram. Sorry. In a quadrilateral, if one pair of opposite side is parallel and equal in length, then it is a parallelogram. Very important statement. In a quadrilateral, if one pair of opposite side is equal in length, and parallel, then it is a parallelogram. Now I encourage you to prove all these things. Okay, it is given in your textbook. Prove it. If you find it difficult, you can comment to me. I will show you how to prove them. Now let us move and see few other types of quadrilateral. We have seen parallelogram in detail. Now next we have rectangle. So what is a rectangle? So rectangle, I will say rectangle is a parallelogram. Rectangle is a parallelogram. with one angle 90 degree. So in a parallelogram, if one angle is 90 degree, then it is a rectangle. Now here, rectangle will satisfy all the properties of parallelogram. So whatever properties we have seen in parallelogram, all the properties are also valid for rectangle. Apart from that, there are few more properties, okay, that we will consider true in case of rectangle. First, that diagonals are equal. Diagonals are equal. And as I said, one angle is 90 degree, you can prove that all other three angles are also 90 degree. So rectangle is a special type of parallelogram in which one angle is 90 degree. And if you measure diagonal, they are equal in length. In case of parallelogram, the diagonals, we have discussed that they bisect each other, but regarding their length, we haven't discussed anything. So if lengths are not equal, we simply say it is a parallelogram, and when length become equal, then it is a rectangle. So all the rectangles are parallelogram. All the rectangles are parallelogram, but all the parallelograms are not rectangle. You keep this in your mind that all rectangles are parallelogram as they are satisfying all the conditions of parallelogram. Apart from that, they are satisfying one more condition, that one of the angle is 90 degree and diagonals are equal, obviously. Next type is, so rectangle, if I draw rectangle, it is something like this. Parallelogram with each angle 90 degree. Now, next we discuss rhombus. Now what is rhombus? So rhombus is also a parallelogram with all sides equal, or you can say adjacent sides equal. In parallelogram, opposite sides are equal. So for rhombus, we define that it is a parallelogram with adjacent sides equal, or say all sides equal. So parallelogram with all sides equal. So it will satisfy all the conditions of parallelogram. Apart from that, it is satisfying one more condition, that its all sides are equal. Now you can prove that in rhombus, diagonals are perpendicular bisector of each other. So you can prove that in rhombus, diagonals are perpendicular bisector of each other. Diagonals are perpendicular bisector of each other. Now what we mean by perpendicular bisector? So perpendicular bisector means they bisect at 90 degree. So here, if I draw a rhombus, it is something like this: A, B, C, D. Okay. Now this is one diagonal and this is other diagonal, BD. And if you see the angle here, BMC, this is 90 degree. So here, in case of rhombus, we have AM equal to CM and BM equal to DM. Also, AC is perpendicular to BD. So this is your rhombus. So rhombus, it satisfies all the conditions of parallelogram. Apart from that, its diagonals are perpendicular bisectors. Next is square. Now square is a rhombus. That means square, it satisfies all the properties of rhombus. So square is a rhombus with one angle 90 degree. So as we discussed about rectangles, rectangle is a parallelogram with one angle 90 degree. Similarly, square is a rhombus with one angle 90 degree. Now when I say that square is a rhombus, so automatically it is a parallelogram because all rhombus are parallelogram. So square is also a parallelogram. So it will satisfy all the conditions of parallelogram. It will satisfy all the conditions of rhombus. Okay. Apart from that, it will satisfy one more condition, that its each angle is 90 degree, and one more condition is that diagonals are equal. Diagonals are equal. Now diagonals are perpendicular bisectors, that is fine, but here diagonals are equal in length. Diagonals are equal. Okay. So rhombus, it becomes square when one of the angle is 90 degree, and when it is a square you will find that its diagonals are equal. There is one more type of quadrilateral, that is called kite. So in case of kite, you will find that adjacent sides are congruent. So this is, if I name it A, B, C, D, then this ABCD is a kite in which AB and AD equal. So adjacent pair AB is equal to AD. We are not saying that anything is parallel. So AB is equal to AD and BC equal to CD. BC equal to CD or DC. BD is BD and AC. Now diagonals are of unequal length. Diagonals are of unequal length. Here diagonal are unequal in length, and larger diagonal bisect the smaller diagonal. Bisect means divide into equal parts. So if this is M, then BM will be equal to DM. But AM will not be equal to CM. Also, your AC is perpendicular to BD. Also, AC is perpendicular to BD. Okay, so this is what about quadrilaterals. Now we have seen the definition of quadrilateral, that it is a closed four-sided figure. Second, the sum of all four angles of quadrilateral is 360 degree. Then we have seen a few special types of quadrilateral, in which we first seen rhombus, in which one pair of opposite side is parallel, the other pair is not parallel. When one pair of opposite side is parallel and other pair is equal in length, then we call that as an isosceles trapezium. Second, we have seen parallelogram, in which both the pairs of opposite sides are parallel. We have seen the properties of parallelogram. Then we have discussed about rectangle. All rectangles are parallelogram. They satisfy all the properties of parallelogram. Apart from that, one angle, or you can say that each angle of rectangle is 90 degree. When it is rectangle, one more condition it satisfies, that diagonals are equal in length. Next, we discussed about rhombus. Rhombus is also a parallelogram with all sides equal. When it is rhombus, then it satisfies one more property, that its diagonals are perpendicular bisector of each other. Then we have discussed about square. Square is a rhombus with each angle 90 degree. And finally, we discussed about kite, in which adjacent pairs are equal in length. The longer diagonal bisect the smaller diagonal. So thank you for being with me in this lecture. In next class, we will see exercise. We will see problems related with parallelogram. Majorly we discuss parallelogram and other figures also. Here and there we will see. Thank you.